Okay, so today we're gonna do this problem, Leetcode 1522, diameter of an array tree. So basically we'll be given a root of an array tree. So you need to compute the length of the diameter of the tree. What is the diameter of the tree? Is actually the length of the longest path between any two nodes of the tree. Notice that this path may or may not pass through the root. For example, given this tree here, we have the root node is number 1, right? And our longest path will pass this root. But for this case, the longest path actually happens in the root number 1 subtree, root number 2, right? So it does not pass through the root. The key to solve this problem is actually think of the concepts of recursion. So basically, we're gonna try to recursively find the subtree's longest path, and the longest path for the parent node is actually here, parent node, parent depth. Let's call it parent depth is equals to the subtree depth plus 1, right? So recursively, we should maintain a global maximum 1. Let's call it maximum 1. This one will be the longest path, longest depth of the subtree. And maximum 2 will be the second longest depth of the subtree, right? And our depth diameter will be max 1 plus max 2, right? Max 1 and max 2 may be equal or they may be not. So notice that we're gonna compare parent path maximum 1, maximum 2 for each subtree. So in this way, after the recursive calls, we will get the global maximum 1 and maximum 2. And eventually we'll get the answer. So let's start it. We're gonna do it in a DFS fashion, I guess. So let's make a class method called DFS. And because we want to actually getting the current node's depth, right? So we're gonna have the exiting condition if not node reaching to the end will return 0, and then we start building from 0, right? And we're gonna have maximum 1 initialize as 0, maximum 2 initialize as 0, and we want to return the longest, so that's maximum 1, right? And how to get the longest? We basically need to traversing through the current node's children, right? And so let's do that for child in node children. And we're gonna recursively code this one to get the children's longest depths, right? And our node depths will be the children's depths plus 1, right? And we're gonna try to maintain the node depths with the maximum 1, maximum 2, right? So if node depth is larger than maximum 1, we definitely would update maximum 1 to the node depth, but at the same time, we want to swap maximum 2 with maximum 1, right? So this one will do a trick here. So node depth with maximum 1, right? And if node depth is not larger than maximum 1, but still it's larger than the maximum 2. So in that case, we'll just only need to update maximum 2, right? Let's do that. And we, when we're doing this recursive code, we can actually just, you know, update our result. Will be the diameter, right? So let's code that in here, because diameter will be the maximum between itself and also maximum 1 plus maximum 2. So by doing that, we call it here, DFS, and our node is actually root. So in this way, we can solve our the problem like this. Let's try it. Okay, passed. Submit. All right, there we go. So that's how we solve this problem.